Hello, in this video, I will explain to you on how to solve this problem. Number 26. The tension at which a fishing line snaps is commonly called the line strength. What the minimum strength is needed for a line that is to stop a salmon of weight 85 Newton in 11 centimeters if the fish initially drifting at 2.8 meter per second, assume a constant deceleration. Okay, so let's draw what we know here. Okay, the fish has the initial velocity here, VO, of 2.8, right? So I'll have 2.8 meter over second there. And then it's drifting there. And finally, it stopped by the fishing line. So I will have VT here is equal to 0 meter over second. Okay, and then the distance when it stopped here, I will have that distance is 11 centimeter. So I'll have delta x here is equal to 11 centimeter. And convert that into meter, I will have delta x here is equal to 0.11 meter. Good. And now here we have our fishing line, right? So I will have this one here, and it will have the force by the tension to the left hand side here. So I'll have the force by the tension. And then we will have this force here by the fish, and it is going there, right? So I'll have the force by the fish. Okay, but then we need to calculate the acceleration first, because we have the F, the force by the fish here, right, on the right hand side, and that will equal to mass times acceleration. And to counter that, that will also equal to Ft, right? So Ft has to be greater than or equal to F fish, right? So we will have to calculate F fish first. Okay, but first we need to know what is the mass of the fish. We know the weight of the fish is 85 Newton. So we have the weight of the fish is 85, but the weight is just mass times gravity. And if the weight is 85, we can calculate the mass, right? So I'll have mass times 9.8. And so I will have the mass of the fish here is 85 divided by 9.8. And the mass here will be, okay, let's see here, where is my calculator? There it is. I will have 85 divided by 9.5. Good. So we will have 8.95. 8 point what? 95. Yeah, 8.95, and the unit here will be in kilogram. Okay, and that is for the mass. But then for the acceleration, we can use kinematics here, right? Because we have VO, we have VT, and we also have delta x. I think we can use kinematics with this formula here. VT squared is equal to VO squared, and then plus 2ax, a delta x, right? And we know all of them except for the acceleration. Okay, Vt is 0, let's plug that in, 0 squared, and then Vo here is 2.8, so I'll have 2.8 squared, and then plus 2, and then delta x here is 0.11, 0.11, and then multiplied by the acceleration. Good. Now we can isolate the acceleration here, so I will have this one here, 0 squared, and then minus 2.8 squared, and then divided by 2 multiplied by 0.11. And I will have our acceleration here. Let's calculate that. So we will have 0 squared minus 2.8 squared, and then divided by 2 multiplied by 0.11. And we will have this one here, minus 35.64, minus 30 what? 35.64. And the unit here is meter over square second. Good. And now we have the mass of the fish here, which is this one, and also the acceleration of the fish, which is this one. We can just multiply them, right? So we have this one. The mass is 8.95, so I will have 8.95, and the acceleration here will be minus 35 minus 64. Okay, and then we will have that one, so we will have what? 8.95 multiplied by minus 35.94, and that will be minus 318.98, minus 318.98, and the unit here will be in Newton. Okay, and then so the minimum strength of this Ft here is needed to counter this one, but this minus sign is just the direction, right? Because we have the Ft to the opposite direction to the force of the fish. So I will have Ft here, the tension, maximum strength, minimum strength I mean, so that has to be greater than 318.98 Newton. So it has to be greater than this. And I think that's all for this problem. Hopefully I did not make any mistakes during my calculation. And thank you for watching. See you in the next video. Bye bye.